Welcome to my talk this morning. I'm extremely happy to see so many of you here, and I'm even more happy to have this talk because I wanted to I wanted to talk about Flutter commands already on several other conferences, but they always took other talks from me, and I never get a chance to talk about Flutter commands. For people who don't know me, I'm probably most infamous for my package Get It, and we will have some marketing pitch in between for my newest package Watch It, and Flutter Command itself is also one of my packages. This talk will be a bit different to other talks because we will see a lot of code, but almost no Flutter code. I spent the last 5 months almost completely in the engine room of a big app, also known as Business Logic. And my goal there was to provide the UI layer the most comfortable data layer that they can use. So the app that I'm working on, and we will see a lot of real code examples from this app, is a social media community app for watch nerds, for mechanical watches. It's called Watch Crunch. And we will see a lot of, I have to show you a lot of stuff, so I will be quite fast. I won't get into every detail. If I get you hooked, then I invite you to check out the readmes of my packages afterwards. But I want to give you an impression what you can do with it and how this looks in real life. And also, we won't only talk about my packages, but also how we made solved some design challenges that we had. And yeah, I called it Coding the Happy Path because one of the probably not often enough talked about topic is how do I handle errors? And we all like to code the happy path of our code and don't want to care about error handling. And if you are as long as I am in the IT business, you realize that there are always some waves of trends, hypes, and what's currently in fashion. So over the last some years, functional programming got more and more in fashion, which has had one strange side effect that people started to dislike exceptions. Because from the functional area, there's always return some result record, and that is passed back through all the layers, and but it makes actually your code quite ugly. So, what's great about exceptions? You really can't ignore them. This is one of it's not to underestimate. Then they can be thrown somewhere deep in your call stack, and you can catch them somewhere completely else, and you don't have to write any code in between. You don't have to pass back any result objects. So it's actually a really powerful tool. The problem, in my opinion, why people don't like exceptions is they don't know where should I handle them. Because if I wrap every call directly with a try except and then maybe pass back a bool value to the next level, so error, it's not really helpful. And then they might miss I might miss them at runtime and it crashes in the release. Also not a good idea. And you don't see from the outside of a function if it throws an exception. So the top 2 points we can solve with Flutter commands. So what is a command? A command is a callable class that wraps a function. Most often an async function. You can also use synchronous. And as it's a callable class, you can assign it directly to an event handler of a widget, for example, that gets called. And itself implements the value notifier interface. So if the wrap function has a result value, it gets published on the .value property of the command, which then can be observed from the UI. So that's only the first step. Then we have a property which is also a value listenable bool is executing, which is changes to true while the command is running, and to false when the asynchronous wrap function has finished. So this can also be observed from the outside, from the UI. And most important, the command catches all exceptions that the wrapped function may receive from wherever, and it publishes this exception together with some more information about the error on another value notifier property of the command called errors. So you can directly listen from the UI with a value listenable builder, for example, or with watch it, we will see later on, to the errors interface and react, show a dialog or something like this. So this means we split the execution path, the error handling, and the busy state in different channels that we can independently observe from the UI, which is pretty neat, because Flutter is a reactive framework. So ideally, we shouldn't await anything. We should observe changes of underlying data, and exactly this is possible with the command. Basically, a command is fire and forget. If you trigger it, it will be executed, and if nobody listens, nobody gets displayed, nobody happens. Yeah, but it completely decouples your part of business logic from the UI, unless you observe it and watch it. Then there's one nice other thing. There's one results property that allows you that you get every state change in one object instead of the different properties. Don't go into this detail. More interesting is there is a can execute property, which you can, for example, wire up to the enabled state of a button. If this command can be executed. Now you might wonder, okay, what's the sense of can execute? I mean, I could, for example, just use the inverse of is executing. If is executing is false, true, then I can't execute it again. But the point is, I can also, when I create a command, I can pass in a value notifier bool as restrictions, which means I can, from the outside, enable, disable an existing command. And this is an extremely powerful concept. So the value on can execute is actually is executing at the moment and not restriction. So if I have connected the active state of a button to can execute, and some other logic outside changes the restriction value notifier, it will automatically switch the state of the button on the outside. And you can go a little bit further. If you have multiple commands, you can take the is executing of one command as the input of the restriction of another command. So the moment one command is running, the other command is blocked and can't be executed. So it's a more, you are describing your behavior in a more declarative way instead of an imperative way. Yeah? This talk is not only over commands. Can't go more deep into it at this point. But I guess you get an idea what you can do with it. I have here a small animation that shows you a little bit how the idea is. If I press the button and I execute a command, so while the async call is running, the can execute changes, the button changes, the async call is still running, and when it comes back with some value, they change again. And so that's the idea how the inner workings of them is. Now, how do I use them typically? My preferred architecture looks like this. I have an UI layer I have a business layer, which is which consists of manager objects. They are typically long-lived singletons, and a manager object groups semantically related functions in one object. Yeah. So I don't have like often blocks are separate objects for everything. I group together several commands typically in one object, in one manager. For example, a user manager will have command to create a user, to delete a user, and things like this. And managers, on the other side, communicate with a service layer, which is the border to the outside of the world. And the communication between the UI and the business layer is completely over value listenables that are observed and calling of commands. We will see some real examples soon. So where do commands live otherwise? Besides of manager objects, they also feel quite comfortable in the state objects of widgets. So if you have a stateful widget, we will see an example where a command is very handy to have there. And we have you can basically use them anywhere where you would otherwise use a function, but you like the possibilities with the error handling and the busy state, for example, that you don't want to deal with this yourself. Now, error handling with commands. You have to. It's what I didn't tell you yet is that a command does not only have a local errors property. There's also a global static error handler in the command class. Now, when you are the default behavior is if there is no one listening on the local errors output of the command, any exceptions will be published on the global one. But you can completely customize this because you can pass an error filter object that conforms to this interface when you create a command. And as you see in the enum below, there are different options that you can route different errors. So you can completely decide should it be swallowed, should it be thrown, should it be passed on global and local, only local. And this gives you a great flexibility. Actually, currently in our app, we haven't done a lot of error handling code written yet, but we know we can easily we can hook it up everywhere on the commands without any problems. So it's not a real problem in the end. This is an example of how such an error filter could look like. It checks, in this case, it checks, is the error an API exception from our backend? And it also has a testing condition with it. If it's the case, then it will pass the reaction that you pass in when you create it. Otherwise, it will call the default handler. We see an example how this is used. So this is on the right side, you see a screenshot of one of our onboarding pages, which consists of a scaffold page with which has a tab view with several for every step several different stateful widget. And in this case, it's the where you input your username, and in the state we are seeing here the state of the tab page in the constructor, which is actually the place typically where you create commands. We define a command. In this case, you create commands with factory functions of the command of the command class, which has different creation functions depending of if the command should accept a parameter, if it has a result, which changes the generic types of the commands also. So in this case, we pass in an async function which gets the current username. It does an API call. Actually, what you see here with the DI user manager, this is the user manager as a singleton that is stored inside Gedit, and we access it over the global instance DI user manager, we get we do an API call, and if everything goes right, we access the onboarding manager, which is the object that links the onboarding process of the onboarding page with changes in the pages itself. So now in this case, I add an API error filter that we've seen before, and it should only check if the error contains already taken. In this case, I want to handle it locally. In the every other case, for example, network error or something like this, it will go to the global handler and show it a toast, for example, for no network currently. And the error is handled is handled in this way. We are listening to the errors property. Listen actually is an extension method of which is defined in the in Flutter command, or more correctly in functional listeners, which allows you to register handlers to value listenables the way it should be, I would say, because it's not you have to add a handler. It's just a listen function, which also can unsubscribe if necessary. So okay, we listen to the errors handler. In this case, we change a property in the onboarding manager, and in a little bit further down in our build method, we have this function from watch property value, which checks the error, and if the error changes, it will rebuild the page with the new error with the new error message. And we also we listen on the is executing, and in this case we update the that we have a small animation on the buttons while it's running. So this is an example where a command lives in the stateful in the widget state, and so it helps you there. And the command itself is linked to the next button. I didn't say this. So if the next button is pressed, the command will be executed. Okay. Short summary. I didn't say it before. Commands are protected against double execution. So while an asynchronous function is running inside a command, you can't execute it a second time. And besides the global error handler, there's also a nice side effect. If the command has a debug name set when you create it, every command execution will call a global logging handler, which is quite nice if you have some if you collect some usage data, you can go over the logging handler in this case. So, short marketing intro. Watching states with watch it, we saw that the command has a lot of value listenables outputs. So it's the question, how do I consume them in the UI? One way is we can use a value listenable builder. The other way is you use new package watch it, which is actually a nicer interface to the API, to the hook principle. So in this example here, we have a simple model object which extends a change notifier. And if we change the name, it will notify its listeners. We register this object inside getIt, somewhere at the beginning of our app. And then in the UI where we use this, we want to access this object. In this case, we use the watch property value, which observes a property of a registered object inside getIt. In case it changes, it will trigger a rebuild of the UI or of this widget, and with the latest value of the username. So you don't need any builders inside the widget tree, and it makes life much easier. Then we will see some other examples a little bit later in the code. So I promised you we want to see some real data, some real code. As said, our app is a social media app, which means we have a lot of feed views of posts that the user make. We have, but also we have list views with, for example, on the right side, where we have all the users that somebody follows, and our backend does provide all this data in a paged manner. So I have always a call with paging if I want to get more data, and it was actually the first time that I had to deal with this sort of API, and so I did some research and checked. There are, I think, at least 3 packages on pub for page list views, and I thought, why should the UI have to know how the API serves my data? Why do I need paging logic in my UI? It doesn't feel right. It would be much easier if it would be completely transparent to the UI. So I came up with this interface, my first approach, that I say, okay, we define a generic interface feed data source for all our list views, and it has an update data command, which has to be called to get the data in the first time from the backend. It has a value listenable bool if currently the next page is fetched, so we can display a little spinner at the bottom of our list views. And it has an item count, which is also value listenable, and it has a function get item at index. That's all. And with this interface, the UI can access endless list views as long as the index is below item count. And if I change the item count, I can access more items. And what I didn't know, this was a little bit my worry when I started with this, is how does a list view builder behave if I change the item count? And I was a little bit worried that maybe the list view might jump or something like this, but it doesn't. Flutter is smart enough that the list view stays in the position if I increase the item count. So the matching widget to this looks like this. We get passed in a feed source, as I've shown, and an item builder. At the beginning, in this case, we watch the item count and we watch the is fetching next page into variables. So if any of them changes, this UI will rebuild and we get the latest data in add item count and loading. I said before that commands are fire and forget. This was not completely true. You can await a command with the execute with future, and this function actually only exists for this case for the pull down to refresh, because the pull down to refresh requires some future, which is not really the best decision from the AP design, in my opinion. But okay, we can solve this by this, that we wire up the update data command with execute with future. Then our items itself, we pass to we get the item index from and pass them to the item builder. And if loading is true, we show a feed view, a little spinner at the bottom. And with this widget, we solve all our list views that rely on underlying data. As an example, how does such a feed data source in the implementation looks like? This is one for the search, where we can search for tags. So we have the real definition of 2 commands. They have 2 voids, which means no parameter input, no result, and they are created in the constructor. And the is fetching next page is wired up to the request next page command is executing. And the item count is wired up to a local value listenable tag count. And get item at index is pretty straightforward. And if we get up to the third item, to the end of the count items in the list, we trigger the request next page command. That we get the next page from the UI. And the update feed data function is also pretty straightforward. We access our backend API, and then we clear our current list. We add them all. Yeah, and the most important, we update the tag count value at the end, and request next page is more or less the same, and we'll just add more items to the list and also update the tag count. So it's very straightforward, and that's all that you have to do to get a page list view that you can scroll forever on the UI side. So yeah, this is a bold statement. As you can see, I'm more or less one of the dinosaurs of the community. And I grew up with the gospel of object orientation, and our god was Grady Booch. So it is, if you think in objects should be mutable because methods are there to change the state of an object. And it's not. I know people say you can make a lot of errors if you use mutable data. It's true, but the really important part is you have to make sure that that you have always a single source of truth of the data. Then you can then mutable data makes life much easier, which we will see in a moment. And especially with the change notifier interface that we have, and we have an UI that reacts to changes, an object that change a value calls the notifier listeners. It's a good match for mutable data. And I know it's currently not en vogue, and everyone says avoid it as hell. In my opinion, it's much more fun and it makes things much easier in many cases. And we'll see an example where we use this. We had one problem. We have several different feed views. For example, one of the main feed. Then, if you go to a user profile, you see a feed of the user's posts. And now, if the user likes a post in one view, we want to make sure that the same post is updated in every other view. If you use immutable data, you have to do something like an event bus or something like this, and everybody has to listen. And I didn't like this idea. So we came up with something else. If I have this view on the left, we have the feed data source, and we do our backend call. We get some payloads from the backend in a specific order. And what we do now is we add there's a global repository for posts, and we create proxies for every item that we get. And this create proxy function here shows you if it doesn't exist yet in the repository, we create a new one. If it exists, we update the data item with the latest item from our backend. And the data entry itself is a change notifier, which will, as if you update the data object in it, it will update, it will notify its listeners, and the proxy objects that are accessed by the view are also change notifiers, so they get notified too, as soon as one of the objects get updated in the repository. And the post proxy itself, as you see here, just reaches into the underlying data, but because of this proxy, I can switch out the data underneath, and the UI will update without updating the proxy object itself. Now we have a second view for the for our user profile, and in this case, we do an API call we get post payloads in another order, other objects, and we do the same thing. But if you look closely here, we have here an example that appears in both lists. Yeah, the feed data source holds the order and which objects which view should display, but the real data is lying uniquely in the repository. So if I update in one view, if I update from there this proxy, it goes down here, notify listeners, this gets notified, and this gets updated too. Another challenge that we had, if we have in a social media app, you have you see your own avatar in the feeds or everywhere where you have your own posts. Now, when the user updates his own avatar in the settings, we want that immediately in all feeds the avatar should be updated. And the other problem that we had was that our backend, it was already existing. It uses up to 4 different types of user objects with different sizes. So some that only contain an avatar and a name, some that has all of it and everything in between. How do we deal with this from the UI? Because I don't want to deal in the UI with this. So for this, we defined a user proxy class, and the user manager has a get user proxy that gets called with, depending on which object I got from the backend, I pass them in. All of them has at least a user ID, and we create a user proxy with the underlying real object. And this here is important. If the source ID is the ID of our current user, I directly return the one proxy that is available for the current user. And this means if I look in how this is used, for example, here in the post proxy, if I access the user of a post, in reality, it will check, is there already a user proxy? And if not, it will call get user proxy with the data of this user. Everywhere where the user proxy is accessed, it will automatically access our current user if it's there, and otherwise it will provide one interface independently of the underlying data. Now I might ask, what happens if not every data is there that I want to have? Yeah, and that's the reason. For example, here the URL property of the user proxy. It checks if it's a user data object, then we have an URL. User data compact, we also have a URL. And in the other cases, we throw an exception, meaningful, because while developing that, we make sure that we don't make any problem. But in case, what do we do in case we have such a user proxy, which is in reality user data tiny, like in some feed view where we have an avatar, we click on it, and we want now to have the full user object in the profile view. For this, the user proxy has a load full user command. So before we switch to the profile view, we trigger the load full user command, and as you can see here, when the user profile tries to access the URL, it checks, is the current user command already running? If it's so, we provide some usable data, which will not throw because it's not null. But we know that a moment later, when the load full user command has completed, we will automatically update the view again in the profile and have the real data there. And the load full user command is pretty simple. It checks if it's this proxy is the current user, then it will load it again from the backend over a different API. Otherwise, it uses another API. And by this, it's extremely. We made the fact that we have different user objects in the background transparent to the UI. The UI always just works with the user proxy. Another thing that's today quite common is, or wished, is that we have an immediately update of the data if the user changed something. Call it optimistic data update. And this is also very nicely can be done with commands. For example, the user proxy has a toggle follow command, and what this does is it will assign the isFollowing override, which is this following override, which, if this is set, if the client accesses the isFollowing, it will use the value of the isFollowing override in this case. So it will assign the isFollowing override with the inverse inverse of the current value, and it will immediately notify the listeners. So the UI gets updated. I follow now the user. After that, we do the API call that really does in the backend the following. And now the interesting part is, what if this API call fails? We are listening in this case here to the errors. And if case there is an error, we just clear the override and we have undone the data change in the UI. Sometimes you can't undo it with just by inverting or by clearing a flag. And for this, actually this is currently only in the pre-release of the current command package. We added the undoable command. For example, here in our profile page, we have a list of questions that a user can answer. And also there, we want to have the UI immediately updated when he changes this value. And for this, we use the undoable command. And undoable command is like the normal command, with the exception. In this case, we have one that will get a parameter p, which is the change in in this question list. But it also gets passed in automatically an undo stack of a type that you can define. So at the beginning, before we update this data, we push the current value of this list onto the stack. Then we update the value in the data structure itself and call notify listeners, so the UI will update, and we do our API call afterwards. Now, if we have an exception in this case, we call automatically the undo handler is called, and this undo handler gets passed in the stack that was previously passed in to the command function. So now I can directly pop the latest value from the undo stack and update the UI again, which allows and you can also the undo command. You can also trigger it with from the outside with the undo function. But in the default setting is, if the command itself throws an exception, I would automatically call the undo handler. I think we are almost done with time, right? Okay. I know this was a lot of stuff. I can only, if I get you hooked with this, with the ideas, check out the readmes of my packages. I try to be exhaustive and to tell you how to use them. And also, I will be the next hour down in the Flutter launch. So if you have any questions, just get to me, and I'm happy to answer everything. And thank you very much.